Chapter 7, Air Traffic Control. You can download the PDF note on the description given in playlist in name Airport Planning and Design. General. Air traffic control is an essential element of the communication structures which support air transportation. Two basic for air traffic control, that is ATC, are safety and efficiency of air traffic movement. Primary function of air traffic control: airport traffic control, to direct aircraft during landing or takeoff and guide them from and back to airways within a predetermined controlling area around the airport. Also to control the taxiing of arriving and departing aircraft on the airfield between apron and the runway. Air traffic control, to regulate aircraft movement in flight along the runway by keeping each aircraft properly separated vertically and laterally. Airways communication, to disseminate weather and air information to aircraft in flight. General or non-airways traffic control, to regulate the movement of aircraft not flying along airway and to prevent interference with airway traffic. This control is required when personnel in flying is very common. Air traffic control network. The network for controlling the air traffic can be divided into three parts as follows: control within terminal area, control over airways, airways communication as visual flight rule and instrument flight rule. Air traffic control network, that is first, control within terminal area, done from the airport control tower which is located in the terminal area. The controller directs the movement of aircraft on the ground and in the air within the airport zone. Information are issued to the pilot regarding airport conditions, airways traffic, visibility, speed and direction of ground, winds, barometric pressures and other relevant information for the safe operation. Control over airways. The control is provided by a number of Air Indoor Traffic Control Center, that is ARTC. Each center controls a certain definite geographical area, thus covering the entire area of the country. These centers are usually located at major airports so as to eliminate the expenses of additional communication facilities. As the aircraft cross over the boundary of one of the control area, it is taken over by the ARTC of another area or by the control tower. ARTC is mainly concerned with flights under IFR, Instrumental Flight Rule conditions. The pilot first gives his flight plan to ARTC, who then decide the altitude at which the aircraft may fly so as to ensure a safe separation from other aircraft operating along the same airways. Air communication. This is usually done through flight service stations. These stations are located at the airport and also along the airways. Their functions are as follows: to relay air traffic control messages between the ARTC and en route aircraft, to give certain information to the pilots before and during the flights regarding the weather changes, navigational aids, airports that are out of use and the procedures at a particular airport, etc. Signaling lamp, meaning of lights and pyrotechnic signals. If the control towers produce a steady red light to aircraft or vehicle, that indicates if the steady red light is produced to the flying aircraft, that is the aircraft in the air, that means the is aircraft do not give permission to the land and give way continue circling. If the steady red light from the aircraft to the control tower produces, that means the aircraft needs immediate assistance. If the control towers provide steady red light to the vehicles and the aircraft on the ground, that means the vehicles or the aircraft has to be stopped where they are. If the control tower produces steady green light to the aircraft in air, that means the aircraft can land, that is the ground is clear to land. If the control towers produce steady green light to the aircraft that are ready for the takeoff, that means the aircraft can take off, that is the clear to take off. If a control tower produces a white flashes light to the vehicle or aircraft, if the white flashes light to the aircraft in air, means that the aircraft can land here on receipt of steady green and wait for further instruction. The white flashing light on vehicle and aircraft on the ground means return to the starting point on the aerodrome. Landing aids. The following aids are available to any aircraft while landing: instrument landing system, precision approach radar or ground approach control, airport surveillance radar, airport surface detection equipment, approach lights. Instrument landing system. It consists of a telecommunication aids to the pilot to enable him to approach the runway and make a successful landing under condition of poor visibility, even when no ground reference data is visible. ILS system provides facility for landing even when visibility is poor. ILS consists of three components as follows, that is localizer antenna, glide slope antenna, and a marker that may be outer, middle, and inner markers. And the component are shown in as in figures. This is the center line of this is the runway, showing the center line of the runway, and this is the extended center line of runway. And the localizer antenna is lies at a 300 meters from the runway end, and a guide slope is located at a 250 to 375 meters from the end of the threshold of the runway and 120 to 195 meters from the center of runway. Localizer antenna. Localizer antenna is a radio transmitter of very high frequency omnidirectional range and emits radio beam signal in vertical plane and indicates to the pilot whether he is left or right to the correct alignment for approach to the runway. That is the this is the beam signals by the localizer antenna that provides the horizontal guidance to an approaching aircraft. If the aircraft is flying left to the extended center line of runway, the localizer antenna guides the pilot to fly to right to be at center of runway. That is. Similarly, if the aircraft is flying left to the right to the extended center line of the runway, then the localizer antenna guides the pilot to fly left to be a correct alignment of the center line of the runway. That is, the localizer antenna guides the pilot to be at the center line of the runway so that he can approach to the runway correctly. Similarly, guide slope antenna. Guide slope antenna is also a radio transmitter of very high frequency omnidirection range, emits radio beam signal in horizontal plane and guides to the correct angle of descent to the runway. That is, this is the radio beam signals produced by the glide slope antenna and provides a particle guidance to the approach aircraft. That means if the aircraft is flying above the correct angle of descent, then the glide slope antenna guides a pilot to fly down to be at a correct angle of descent to the runway. Similarly, if a aircraft is flying below the correct angle of descent, then the glide slope antenna guides a guides pilot to fly above to be at a correct angle of descent to the runway shown in figure. Thus, the guide slope antenna guides a aircraft or a pilot to be at a correct angle of descent to the runway. That is, if the aircraft is flying above the angle of descent, then the glide slope antenna guides pilot to fly down to be at a correct angle of descent. And similarly, if the aircraft is flying below the correct angle of descent, then the glide slope antenna guides pilots to fly above to be at a correct angle of descent. And third component is marker. Markers are also small radio transmitters which serve as a position reporting points. As pilot passes over the marker, he finds a visual indication. This is the visual indications that showing the outer marker, middle marker and inner marker. As he passes over the marker, he finds a visual indication in cockpit and receive a high pitched steady tone through his earphone. Then the outer marker lies at a distance of 6.5 to 11 km from the end of the threshold of the runway. Similarly, middle marker lies at a distance of about 1050 meters from the end of the threshold. And similarly, the inner marker lies at a 75 to 400 meters from the end of the threshold of the runway. When an aircraft is approaching to the runway and it crosses over the outer marker, the outer marker produces the radio beam there and, and the pilot sees the visual indications of blue light blinking showing that it crosses the outer marker at a distance of 6.5 to 11 kilometers from the threshold of the runway. And similarly, when the aircraft is flying and approaching to the runway and crosses over the middle marker, there is a visual indications of amber light blinking showing that the aircraft is passes cross over the middle marker at a distance of 1050 meters from the threshold runway. Similarly, when the aircraft approaching to the runway, as it crosses over inner marker, the pilot see the visual indications of white light showing that it crosses over the inner marker at a distance of 75 to 400 meters from the threshold of the runway. And this picture shows the schematic diagram of the instrument and landing system, and this is the welding fix. Each aircraft is brought to the welding fix by means of in-road aids. It is then taken over by control tower. If two or more aircraft have reached the welding point simultaneously, they are detained by control tower and directed to keep moving around in space with a vertical separation of at least 300 meters. After every 2 minutes, the airport control tower directs the aircraft to the bottom of the stack to move out of for the final approach to the runway. Simultaneously, the other aircraft is in the stack are instructed to descend to the next lower level and keep moving ground. Then the aircraft is picked up by the localizer antenna and glide slope antenna for the safe landing. Precision approach radar. It serves as same purposes of an instrument landing system, that is ILS, except that the guidance information reaches the pilot through his hearing aids. PAR gives the controller the pictures of descending aircraft both in plan as well as in elevation. The controller checks the alignment and the guide slope of the aircraft. Thus, no navigational equipment is required in the aircraft. Airport Surveillance Radar ASR. It is an instrument which provides to the controller at the tower an overall pictures of all the aircraft within the air space and surrounding the terminal. It is effective up to at a distance of 50 kilometers to 100 kilometers. The relative horizontal position of the aircraft are shown as pips on the scopes. As the aircraft move, pips leave a luminous thereby direct indicating the direction of the movement of the aircraft. ASR does not indicate the altitude of the aircraft. And this is the picture showing the airport surveillance radar. Airport surface detection equipment. During a poor visibility condition, the controller finds it difficult to regulate the taxiing of aircraft as he cannot see the aircraft clearly. Airport surface detection equipment, that is ASDE, is a short range radar which gives to the controller a pictorial display of the runway, taxiway, terminal area and shows the position of aircrafts. Even during restricted visibility, this assists the controller to regulate the traffic on the airport. This is the picture showing the aircraft surface detection equipment that's showing the position of all aircraft and vehicles within the airport area. Approach light system. This is a system of high intensity lights that extend outward from the approach end along the projected center line of the runway. This provides visual reference to the instrument runway during the transition from instrument flight to visual flight. The system consists of a horizontal 12 feet bar of high intensity lights spaced 100 feet apart longitudinally for a distance of 1400 to 3000 feet. Each bar contains in addition condenser discharge light. These flash in sequence toward the center of the runway. This is the approach light and PAPI lights. PAPI lights is precision approach path indicators, is a system of visual approach indication designed to provide visually the same information that a guide slope unit provides electronically. Normally, 4 lights units in one row are placed 1000 feet in from the runway threshold. The lights are placed 50 feet from the runway edge. The lights unit have beams elevated so that a specific approach slope is indicated through the proper combination of red and white lights. For example, 2 red and 2 white. When an approaching runway is in correct angle of descent, that is normally 3 degree of angle of descent, the pilot sees the PAPI lights as a 2 red nearer to the runway edge and white apart from the red, and this is the correct angle of descent that shows 2 red light and 2 white light. Similarly, when an aircraft is flying above the, this is the correct angle of descent when the aircraft is flying or approaching the runway above the correct angle of descent, that is above than 3 degree, the pilot sees one red and three white light. Similarly, again, when the aircraft is approaching above or too high, the pilot sees the PAPI lights as all four white lights. Similarly, when an aircraft is approaching the runway below the angle of descent, that is less than 3 degree, the pilot sees three red lights and one white light. Similarly, when a pilot's aircraft is approaching the runway two below than two below than two below than correct angle of descent, that is 3 degree, the pilot sees four PAPI lights. And this is the picture showing the correct angle of descent, that is if the aircraft is approaching to the correct angle of descent, that is normally 3 degree, the pilot sees two red and two white. When an aircraft is approaching the runway above the normal angle of descent, that is 3 degree greater than 3 degree, the pilot sees one red and three white or all four white lights. When the pilots when an aircraft is approaching below the correct angle of descent, the pilot sees three red and one white light or all four red lights of PAPI lights. Now please like, share and subscribe for more video lectures, tutorial solution. Please follow the link given in description in playlist airport planning and design for the download of PDF note